Well, this video and the next one explains everything you need to know about the oxidation of alcohols for IB chemistry. 10.4.3 after this one will kind of finish it off. There are three sorts of alcohols. A primary alcohol, if you oxidize it, hold on, what's that kind of square brackets with an O? Well, that means oxidize. For IB, that is heat with acidified potassium dichromate solution. You need to remember that formula for dichromate. And if you don't say acidified and if you don't say heat, it's wrong. You don't need to say potassium though. If you oxidize a primary alcohol, it makes an aldehyde, and if you continue oxidizing it, it makes a carboxylic acid. That's primary alcohols. Let's look at secondary alcohols. Oh, but before that, what is the color change of this oxidation? The IB loves this question. Dichromate is orange, and when you warm it with acid, it turns green. So chromium goes from +6 to +3 oxidation number. And just remember traffic lights. It goes from orange to green. Orange to green. All right, so for the secondary alcohols, when you oxidize that, you get a ketone. Now you see why you had to learn all those functional groups. And a tertiary alcohol, there's no reaction using acidified dichromate solution. Sometimes the IB is a bit cheeky, and they say that by burning it, you can oxidize it to carbon dioxide and water. That's true. You can burn it to make carbon dioxide and water. Well, what if you need to collect the intermediary product, the aldehyde, when you're oxidizing a primary alcohol, and you don't want the carboxylic acid? Well, the simple answer for that is the word distillation, and that will allow you to collect the aldehyde and not the carboxylic acid or the alcohol in your little product vessel. The IB have never asked much detail about that, but part of me thinks that they might one day. So if the question was, I want to oxidize a primary alcohol to an aldehyde, but not the carboxylic acid, how would you do that? Distillation, that's the answer. I wish that I hadn't done methanol. I wish I'd done ethanol, so I'm changing that by putting CH3 everywhere. It's a bit messy, but bear with me. So ethanol goes to ethanal, goes to ethanoic acid. The primary alcohol turns to the aldehyde. That's good, I want that, but I don't want the carboxylic acid. And it will turn into the carboxylic acid. There's not much I can do to stop it. So how do I collect the intermediary product? Well, their boiling points are different. The ethanal just has a dipole-dipole intermolecular forces. The others have hydrogen bonds. And so I can separate them based on their boiling points as I make them. So if I heat it up in my distillation apparatus, the one that will get the furthest up the column, because it's easiest to turn into a gas, is the ethanal. And when it hits the cold water going through my condenser, it will drip out in the form of a liquid, ethanal. It's a little tricky because you have to have a thermometer and make sure that that's above 20 degrees C there. Otherwise, if it's below 20 degrees C, it won't reach the little neck as a gas, my desired product. The other two chemicals go up and down, up and down. They don't make it to the little exit into the condenser. It seems complicated, and you're unlikely to be asked to recall this. The word distillation will do. And so I can collect my aldehyde, leaving the reactant and the other product behind in the reaction vessel. Again, forgive my clumsy CH3s here. So if the IB wants to ask you how you turn an alcohol into the carboxylic acid, the final product, then you have to use the word reflux, just reflux. So the chemicals go up and down as you heat them, up and down here, mixing. They never escape, but they go up and down, heat and react, and form the final product, if you leave it long enough, of course. So let's look a little bit more at reflux. Now, if this is you, and that's your stomach, the contents of your stomach are prevented from going up your esophagus by a valve there. And if I was to turn you upside down and shake you, there'd be no problem. Your stomach would stay, the stomach contents would stay there. But if that valve's broken, and I turn you upside down, It all comes out of your mouth. Nasty. This seems rather random, Thornley. What's this got to do with reflux? There's something called esophageal reflux, where the contents of your stomach goes up and down the esophagus. And that's called reflux, and that's a disorder. A physical disorder.